about 1,470 light-years from Earth. In the constellation Cygnus within the Milky Way galaxy, you'll come across the most bizarre star we've yet observed. Officially designated KIC 8462852, it's also known as Tabby's star and Boyajian star, after American astronomer Tabitha S. Boyajian, who led much of the research into it. It also has another name, WTF star, for reasons that'll become obvious. Because while it might not seem to be particularly unique at first, it's actually experiencing irregular, unexplained dimming. It dims by as much as 22%. And though the star was first observed in 1890, astronomers didn't notice the changes in brightness until 2011. The star's behavior was so weird that the algorithms NASA used to sift through Kepler's data didn't pick up on it. That duty fell to a group of amateur scientists making up the Planet Hunters project, a project where ordinary people helped analyze data from Kepler. 4 years later, the official research was finally released. Boyajian's star was experiencing consistent dimming, presumably from something passing in front of it. But what that something is has caused widespread debate. The first explanation you might think of is that maybe nothing is amiss with Boyajian's star. Maybe the problem lies with Kepler. Could a malfunction on Kepler be to blame for these anomalous readings? Well, that was NASA's first thought as well. Research showed that no matter which of Kepler's detectors was pointed at the star, the data was consistent. Meaning either Boyajian's star is dimming, or all of Kepler's detectors are faulty, but only when pointing at this one particular star. For once, the simplest explanation is the weirdest. And something more interesting is definitely going on. Since the problem certainly rests with the star, could it be that Boyajian's star is simply nearing the end of its life and getting dimmer? Boyajian's star is an F-type main sequence star, slightly larger and hotter than the Sun, with a shorter expected lifespan, somewhere between 2 to 4 billion years. But there's no evidence that Boyajian's star is dying. Despite the dimming, it's burning steadily and couldn't be more ordinary. It's whatever's passing between Boyajian's star and Earth that's unusual, and there are many theories about what that could be. The most obvious is that some kind of large celestial body is causing the planet to dim during a transit, like an exoplanet. But this planet would have to be of unprecedented size. Jupiter would only block 1% of the light from Boyajian's star, so we'd need a planet 22 times bigger than that to achieve this dimming, which would be double the size of our Sun. Suffice to say, Kepler would have been able to tell if the dimming was caused by a planetary transit, especially one of this size. Another theory blames the star's behavior on a large group of comets orbiting it and dimming it when they transit. But it's doubtful that such a large number of comets could exist. And if they do, we still have a mystery on our hands because that's strange in and of itself. A more promising theory blames a certain type of moon for the star's behavior. A plunet, or orphaned exomoon, is the moon of an exoplanet that has lost the planet it orbits. The plunet in question would have to be an enormous moon that was once in orbit around a gas giant, and it would need to be disintegrating as it passed in front of the star. In this scenario, the material being ejected by the moon as it's slowly destroyed would cause the dimming, rather than the moon itself. Simulations that have been run here on Earth have proven that this could be the case. But the explanation could also be a lot simpler. The theory favored by Tabitha Boyajian herself is that there's an enormous amount of dust occluding the star. The degree of dimming observed is inconsistent across different wavelengths, with more dimming of ultraviolet light than infrared. This all implies that whatever's blocking the star isn't a solid object at all, but something diffuse, like a large cloud of dust or debris. In NASA's words, the star could be surrounded by, quote, an uneven ring of dust in orbit around it. Such material could be shed from a plunet or from a planetary collision. Such collisions are rare, however, and researchers would expect to see an infrared glow from the leftover heat. Alternatively, one research team has suggested that Boyajian's star might be consuming a moon or planet that got too close. Yet another culprit could be an orbiting gas giant with an enormous ring system. Planetary rings can look huge, but actually contain very little matter. Saturn's rings, for instance, have around half the mass of the Antarctic ice shelf, despite how big they appear. We have observed space dust causing dimming before in a specific type of star, YSO dippers. A YSO is a young stellar object, a celestial body that is on its way to becoming a star but isn't quite there yet. And a dipper is a subcategory of YSO where dimming is observed. Stars form out of swirling gas and matter, and in a young star, it might not be able to absorb this material very efficiently, meaning it has a low accretion rate. A lot of material can end up orbiting the center of gravity in a large accretion disk, which can block what light the YSO is able to produce. But Boyajian star isn't a YSO. It's a main sequence star in the middle of its lifespan. There are theories that there could be a YSO or additional star in the same system developing an accretion disk, but these generally involve different dimming patterns. In early 2021, a team of astronomers led by Logan Pierce at the University of Arizona announced that Boyajian star isn't alone. It actually has a companion red dwarf star, designated KIC 8462852b, making it a binary stellar system. The researchers posited that this could be, quote, a potential source of instability in the long-term evolution of the system and could excite chaotic orbits of objects in the system. However, it was unlikely to have a direct influence on the brightness of Boyajian star, as they're separated by a wide margin of 880 astronomical units. We've considered natural explanations, but what about unnatural ones? Another object capable of dimming a star would be an alien megastructure like a Dyson sphere, or more plausibly, a Dyson swarm. A Dyson sphere is an enormous spherical megastructure that encompasses an entire star in order to siphon off all the energy the star produces from nuclear fusion. A Dyson swarm has the same purpose, but is made of many small objects, potentially as small as satellites or as large as orbital space colonies, which could make it easier to build. But could either of these things be responsible for the specific pattern of dimming shown by Boyajian star? While it's exciting to think that we may have stumbled across a stellar engine made by aliens, and only 1,470 light-years away at that, what we know about the star just doesn't line up with this theory. Again, the way the star is being dimmed suggests that something large and diffuse is getting in the way, like dust, rather than one opaque object, like an alien megastructure bigger than a star. In fact, if the Dyson sphere was doing its job properly, we might not be able to detect Boyajian star at all, because so much of its energy would be going directly into the sphere, rather than escaping and getting all the way to Kepler's detectors. But it could be something even more ominous. Forget a swarm of comets. There could be an entire alien space fleet lying low, waiting for an opportunity to invade Earth. Whatever's going on with Boyajian star must have a concrete cause, but how long it will take us to come up with something that explains everything is anyone's guess. And that's why Boyajian star is currently the most interesting star